Hello, in this video I'm going to review the grade 11 functions first practice quiz that's made up of I guess 23 questions. That's what it says here. So I'm going to start off and I'll do solutions on the left side as I watch or look at the questions on the left. So fill in the blanks. Write an equation for a family of quadratic functions that has roots at x is equal to, so one root is at x is equal to 4 over 5. And the other root is x is equal to negative 2 over 3. So the way to get these roots is to actually, first of all, there's a couple of different ways of doing it. One way of doing it is to move the entire term to the left side. We can easily do that. This one will become x minus 4 over 5 is equal to 0. And this here will become x plus 2 over 3 is equal to 0. Now we don't like to have fractions in our final equation, so this equation on the left, I'm going to multiply every single term by a number that'll allow me to get rid of the denominator, and that number would be 5. If I multiply every single term by 5, what will happen is the middle term here, 4, will get multiplied by 5, and then I'm also dividing by 5, so that 5 will cancel out. So I will end up with 5x minus 4 is equal to 0. And on the left, I'm also going to multiply by 3, and by 3. 3's will cancel out in the middle here, and then I'll get 3x plus 2 is equal to 0. And those are my two x-intercepts, so when I actually go ahead and write the equation, I will write y is equal to a. We always write in that a because that's what makes it a family of functions. A can be anything within a single family. And then I'll have 5x minus 4 and 3x plus 2 as my two factors. That's it for the first one, so that's what I would write here. So y is equal to a, 5x minus 4, 3x plus 2. Order doesn't matter because I'm multiplying everything. And also instead of y, I could have written f of x, and actually I just noticed it's actually already written here, so I don't have to write that. So just a and then the rest of the brackets. Evaluate the following expression. All right, so now it's asking me to evaluate the following expression. So let's go ahead and do that. Let's just clear this. Okay, give me just 1 second. Can maybe forward the video since I'm being so slow on getting rid of all this. There we go. I thought I could just go backspace, but I can't. Anyway, moving on. I want to have black. There we go. Evaluate the following expressions. G of 10. Well, this should be pretty straightforward because now I have to look at my g function, which is g of x is equal to negative 3x minus 1. Well, then g of 10 will just be negative 3 times 10. Minus 1, and that'll be negative 30 minus 1, it'll be negative 31. Similarly, I can do the f of 3, that means I'm going to plug in 3 into the f function, so it's going to be 3 squared minus 7, that will be 9 minus 7, which is 2. And then h of negative 2, in my h function, I'll plug in negative 2 for x, so I'll get negative 8 as the answer. D says, find the value of x if j of x is equal to 5. So now I have to look at my j of x function, and j of x is equal to 2x minus 9. And I'm told that the entire j of x, not x, the j of x is equal to 5. So I'm going to make the left side equal to 5, and then I have to solve for x. And this I'm going to do by using algebra, move the 9 over, and that'll get 14 is equal to 2x, dividing both sides by 2. I'll get x is equal to 7. So that's my answer here. Fantastic. Moving on to the third question. If the quadratic function, and it gives me the function here, it asks me where the vertex is. So this is in fact doesn't require to do any math. The vertex is already shown. If you review the notes on the vertex form of a parabola, you'll know that the vertex is located at negative h comma x. And that would be the x coordinate changes. So the plus 2 becomes minus 2. The minus 10 stays. So it's negative 2 comma negative 10. The negative 3 has nothing to do with the vertex. It's all about negative 2 and this negative 10, or the 2 that becomes negative. Moving on. Quadratic 2x squared plus kx plus 2 has exactly one x-intercept. So as soon as I think of one x-intercept, I'm thinking to myself, that means the discriminant, which is b squared minus 4ac, is equal to 0. Right? That's the rule. The discriminant tells us the number of x-intercepts. And then I'm asking you, what is or are the values of k? There could be more than one. So my equation is 2x squared plus kx plus 2 is equal to 0. So in this particular equation, the 2 is my a, the k is my b, and the 2 is my c. So you need to be aware that the number in front of the x squared term is always your a, regardless of what that is. I could have written there a minus 2 x squared. Guess what a would have been? A would have been a minus 2. So anything in front of the x squared is considered its coefficient, and it's equivalent to a for these types of problems. And then similarly, anything that's in front of the x term, it could have been k in this case, but it could have been k plus 1. I could have just put in k plus 1 x, and then the entire k plus 1 would become my b term. Similarly for c, I could have just written k plus 4 for c, and that would have been my c term. So it doesn't have to be like a number. It could be variables or letters as well. And I could easily do that to kind of try and throw you off. Anyway, okay, so now that I've got my a, b, and c, I can go ahead and figure out what the discriminant is. So b is k, so I'll have k squared minus 4, a is 2, c is 2, making it equal to 0. And here I can figure out that it's k squared minus 4 times 2 is 8 times 2 is 16 is equal to 0. And then I'll say k squared is equal to 16. And then I'll take a square root of 16. And what's square root of 16? Well, you should know that it's plus or minus 4. So there's actually two values. When I take a square root of 16, I can get plus 4 because 4 times 4 is 16. But when I take a square root of 16, I can also get negative 4 because negative 4 times itself is still 16. So that's there's two answers here. So I circle that. Moving on to the next question as I erase my slide on the right side here. Factor using product sum method of factoring. Okay, so this is like straight from grade 10. Gotta be comfortable with this. I've got to do it. Let's go ahead and see it. It's a simple trinomial because there's a 1 in front of my x squared term, which makes it simple, which means I can do this in one step. Minus 7x plus 8. If you're not sure, please watch the video on simple and complex trinomials. So here I really have to look at the last term. And again, I have as equals 0 here, but I didn't, oh, actually I don't. I don't have to have a 0. Regardless of whether I have equals to something on the right side, I would still be using the same method. So no zeros there. Okay, so I've got to find a product of 8, and my sum is negative 7. So what two numbers multiply to 8, positive 8, and they at the same time add up to negative 7? With some thinking, you'll know that those two numbers are negative 8. Oh, and sorry, this question was changed in the test. I told you to make the 8 a negative, so I apologize. The product is negative 8, and I think I said that during the quiz. The product has to be negative 8. And if you think it out, the two numbers are negative 8 and positive 7. Sorry, positive 1. So negative 8 and positive 1. And that will add up to negative 7, and it will multiply to negative 8. So this one question had a typo. It should be minus 8 at the end here. Now if I go ahead and factor this, I will end up with x minus 8 and x plus 1. So the numbers that I came up with go right into the equation. I have to do nothing else. I'm finished with this because it's a simple trinomial. I think we're going to do a complex trinomial next, but the simple trinomial, you can really just, it's one step long. You do not have to do anything else because a simple trinomial has a shortcut. Okay, next question here says when f of x is 3x minus 5, find the value of x when f of x is equal to 1. So we already had a question like this, very similar to it a few questions ago. So it's asking me to find x when f of x is equal to 1. Well, it's also telling me that f of x is equal to 3x minus 5. So what I'm going to do is I'm going to plug in, make f of x, the entire thing is equal to 1. It's not x is equal to 1, it's f of x is equal to 1. And then I go about solving this. It'll be 1 plus 5, which is 6, because I'm moving the 5 over, is equal to 3x, and then I'll divide both sides by 3. and I'll get x to be equal to 2. Awesome. 7, what is the domain of this function? So when we talk about domain and we're given an equation, there's two concerns. One concern is when we have a denominator, and that's the case. This is the case with a denominator. We said in class that the denominator cannot equal 0. Well, in our case, what's the denominator? It's 5x minus 7. So that denominator cannot equal to 0. And now I just go about solving for x. I can pretend that this cannot equal to is the same as an equal sign when I do math. So the first thing that I'm going to do is I'll move 7 over, and then I'll divide both sides by 5. So what's my domain here? So the domain will be x is an element of real numbers. It can be any number except 7 over 5. So that would be the second one here. The domain cannot be 7 over 5. What is the vertex form of 2x squared? So to find a vertex form of something, you need to have it in a vertex form. And in order to do a vertex form from a standard form, we need to complete the square. So let's go ahead and do that quickly. The first step in completing the square is dividing out 2, or the leading coefficient. Whatever this leading coefficient is, you got to divide it out of the first 2 terms. That's it, just the first 2 terms. So it's going to be 2 bracket x squared minus 4x. The plus 3 is when I talk in class, it reminds me of me when I first moved to Canada. I didn't have any friends, so I was always left out. So the plus 3 gets left out like I did when I was a newcomer to Canada. Now the next step is taking this negative 4. What do I do with it? This middle term, just the coefficient, not the x, just the number. I'm going to divide it by 2, and then I raise it to an exponent 2. So what's negative 4 divided by 2? It's negative 2. And then if I raise that to an exponent 2, I'll get 4. So that 4 is the number that I now add and subtract. So this 4 that I just came up with, this 4 here, when I divided it by 2 and raised it to an exponent 2, that's what I always do to the number. I always divide it by 2 and raise it to an exponent 2. Whatever number I get, I add it and I subtract it from this expression, and that's done in the brackets. And then I have my plus 3. The next step includes the negative number, the negative 4, to be kicked out. So it gets kicked out of the bracket, but before it gets kicked out, it must get multiplied by whatever the number is at the front. So I got to multiply them first. So what we'll end up getting, so the 2 will still stay in the front. My bracket is now a trinomial because it only has 3 terms in it. The plus 3, that's me when I first moved to Canada with no friends, I'm still there. But now I got this negative 4 that's going to get multiplied by 2, and it's going to become negative 8. And that gets kicked out here with me. So I've got plus 3 minus 8 at the end, and that's going to just be minus 5. I can go ahead and collect like terms. I also have 2 at the front that never changes. Once I factor it, the 2 will always stay. And the key here is to recognize that this here is a perfect square. That's what you manufactured. You're going to squeeze that in or factor that into square root of the first term, which is x, minus, since there's a minus here, square root of the last term, square root of 4 is just 2, and then all of that squared. You have now successfully factored this expression. So it was in a standard form, and through a series of steps, you have put it in a vertex form. And I will just go ahead and select question or answer C here because that's the correct solution. Awesome. Complete the square and identify the vertex of the quadratic. I'm going to do this super quick. It's the exact same thing as the question before, except now it's also asking me to identify the vertex. So I actually have to write it in. So let me go ahead and see what this would be. And again, I'm doing it super fast because it's literally the exact same question as what I just asked. I'm going to factor out a 3. I'll end up with x squared plus 4x. And then I'm going to use the middle term, divide it by 2 and square it. I know that that's going to be plus 4 minus 4, and then I still have the minus 1. So you can tell I'm combining steps here. My trinomial is going to become x plus 2, all squared, very similar to the last question. The negative 4 is going to get kicked out with a positive 3, so it'll be negative 12 minus 1, which will give me negative 13. So that's my completing the square. There we go. I've done it in only a couple of steps with practice, and I did put up an extra worksheet. You guys should be able to do the same thing. My vertex is negative 2. Again, it's this value here, just the sign changes. and the negative 13 is my y value. There we go. So how am I going to write this? I could either add attachments, meaning I could take a photo of this writing and put it in as an attachment, or I can just write it in as 3 bracket x plus 2 to the exponent 2 minus 13, comma, vertex is negative 2, comma, negative 13. So this would be sufficient, but I would like you to add an attachment that shows me your steps so that I can see what it is that you're doing. Okay, over here, I'm asked to simplify. Looks like I already randomly selected the third one to be the answer. Let's see if I was correct in my randomization. 4 root 3 minus square root of 27. I'm asked to simplify. Can't do anything with the 4 root 3. The square root of 3 cannot be broken down. Square root of 27 can be into 9 times 3. Why in the world would I do that? Because square root or radical problems allow us to break up the radical into its constituents if they're being multiplied. And what will I end up with here? Square root of 9, well, that's a beautiful number. It's nothing more than 3 root 3. And look at what I come up with. Now I have like terms. I have both root 3's. And when I'm adding or collecting like terms, I treat this radicand, similar to what I would do if they were x's. If I had 4x minus 3x, my answer would be 1x. Same way here, 4 root 3 minus 3 root 3 is just 1 square root 3. So the answer is square root 3 here. Fantastic. Question number 11, fill in the blanks. Okay, so if you read this, it's asking for a maximum. So, and there's a hint there. It's telling me you have to complete the square. You just have to. So you might say, oh man, this is so hard, but it's not. I've done it twice already. Let's go ahead and complete the square. It's 1, 2, 3, 4, 2, and then t squared plus 0.0203 t minus 1.24. So if I complete the square, the process is take out the leading coefficient, divide the first 2 terms by it. So I'm going to divide 1, 2, 3, 4, 2. Both of the first 2 terms, same way that I've done it before, I'm going to divide them by the leading coefficient. And that leading coefficient, of course, I'm going to have to put the value at the front. And then I'll start with a bracket, and this divided by negative 0.00002 is just going to be t squared. 0.0203 divided by negative 0.002. Okay, let's take out the calculator and figure it out here. So it is 0.0203 divided by 0.12344 zeros and a 2, and it's negative. I'm going to remember that it's negative, but here I can go ahead and give it a negative. What's my answer? Negative 1,015. So that's going to be minus 1,015t minus 1.24. What do I do with this middle term now? I'm going to divide it by 2 and square it. So let me go ahead and divide it by 2 on my calculator here, equals, and then I'm going to raise it to an exponent 2. I'll get 257. Wow, that's a big number, and I know you're thinking like, I don't like this. Well, guess what? Neither do I. But let's go ahead and do it. T squared minus 1,015t. And then I'm going to add and subtract this number here that my scientific calculator gave me. 257.556.25. And also subtracting it, 257.556.25. And I'm just going to go ahead and use my entire screen here. Close off my bracket, minus 1.24. The next step in completing the square is getting rid of that negative, kicking it out of the bracket, but I also have to multiply it by 0.0002. So again, my calculator will come in handy. So this number here, I got to multiply it by 0.44 zeros and a 2, and that's a negative. And, oh snap, I think I did it wrong. Okay, let me just go the number again, 257.556.25, and it was negative. And divide that, or sorry, not divide, multiply that by 0.00002, and that's also a negative. And I'll get 5.15. So when I kick that negative out, I will end up with negative 1.24, which was always there, plus, what was the number? 5.15. 5.151125. That's awesome. And then I can subtract 1.24 from it to figure out what that term is. But now I'm going to worry about my middle piece. So I'm at negative 0.00002 bracket t squared minus 1015T plus 257,556.25 and bracket here. And now I have to again recognize that this triple or trinomial in the middle here, that's a perfect square that I've manufactured. I can raise it up to an exponent 2 and take the square root of the first term, which is just t, take the negative that's here already, and do a square root of the last term. So that's 257. Let's go ahead and figure it out. 257, 556.25, square rooted, right? I'm taking a square root of it. 507.5, 507.5. That's what I get. I'm going to collect the like terms here for y. So I got what? Negative 1.24. Let me just clear this. 1.24 negative plus 5.15, 1125 equals, should be 3 point something, 3.9. Okay, so plus 3.9. I'm just going to round it to 3.9. I'm at the end now. And there's a negative 0.00002 at the very front, and that's my Q, which I think is heat in this problem. I can't remember. But let's go ahead and take a look. What's the problem actually asking me now that I've completed the square? The problem says, for what gas temperature is heat loss maximized? So I need to find the T at the vertex, right? Because maximize means that the T is at the vertex. Well, T value of the vertex is this value right here, which of course I have to change the sign when I put in the vertex, and it's 507.5. So at the end of all of this, I really don't even need the 3.9 here, because that is the Q, which is a heat loss. So that's, if I was asked about heat loss in BTUs per cubic feet, I would plug in 3.9, but I'm asked for the temperature, 507.5. You will